All right, so what I want to do on this unit circle is go around and fill in all of the points here. So for example, this right here, this is the point 1, 0. And then let's do the other easy ones. This one up here is 0, 1. This one over here is -1, 0. And this one down here is 0, -1. So those are the 4 easy ones to do. All right, and then we talked about these on Wednesday. If I were to take this arc length here, coming up to this point right there, what's that arc length? That one's pi over 4. That one's pi over 4 because it's halfway between this one and this one. And this distance would be pi over 2. So this is pi over 4. So what were our x and y values for pi over 4? Square root of 2 over 2. Square root of 2 over 2. Once you know this one has square root of 2 over 2, square root of 2 over 2, you should be able to very quickly fill in 3 more points. Where are the other 3 points that I can fill in? It's equivalence in the other quadrants, correct? So this one in the middle here, over here in quadrant 2, this one has to be negative square root of 2 over 2 and positive square root of 2 over 2. And then I can jump down here to the third quadrant. And the one in the middle, both negative, correct? In the third quadrant, x and y are both negative. Negative square root of 2 over 2, negative square root of 2 over 2. And finally, this one over here in the fourth quadrant, this one square root of 2 over 2, negative square root of 2 over 2. All right, so how is this useful? Let's say I gave you the arc length 5 pi over 4. Where is 5 pi over 4? Which quadrant is that in? Quadrant 3, that's correct. Why is it in quadrant 3? So this is 1 pi, which is 4 pi over 4. So 5 pi over 4 is just a little bit more. So I go here to 5 pi over 4, that's in quadrant 3. What's the reference number? Pi over 4. If I have something with a 4 on bottom, 5 pi over 4, 7 pi over 4, 3 pi over 4, the reference number is always pi over 4. Always. Okay? Once I know the reference number, I know the point. I'm in quadrant 3. I know my reference point is square root of 2 over 2, square root of 2 over 2. Since I'm in quadrant 3, they're both negative. All right, let's do the same thing for the other ones. What's this arc length coming up to here? Well, if this one's pi divided by 4, this one's a little bit smaller, so it has to be divided by something a little bit bigger. It has to be divided by 6. So this arc length here, from here to here, it's a little bit smaller than pi over 4, which means I had to divide by a bigger number. That's pi over 6. Okay. So what are the x and y values for pi over 6? Root 3 over 2 and 1/2. All right, and then again, I can use my circle, I can use symmetry to fill in a bunch of other points. If I start here and go straight across, I get to there. So what are the coordinates of that point? Negative square root of 3 over 2, positive 1/2. Okay. And then, let's see, I guess I can go from here, and I can go straight down to get into my spot in quadrant 3. So this one's both negatives. Negative square root of 3 over 2, negative 1/2. And then I go from there, and I come straight across. Square root of 3 over 2, negative 1/2. Okay, so now let's say I gave you the angle 11 pi over 6. Which quadrant is 11 pi over 6? Quadrant 4. Why quadrant 4? It's just a little bit less than 12 pi over 6, which is a fancy way of saying 2 pi. Yeah, that's the way I tend to think of it too. So all the way around would be 2 pi, which is 12 pi over 6. So 11 pi over 6 is just a little bit less. So it's here. What's the reference angle for 11 pi over 6? Pi over 6. Same deal. If I had a 4 on bottom, my reference is always pi over 4. If I have a 6 on bottom, my reference is always pi over 6. So that gives me my reference number, pi over 6. Once I know my reference number and I know this fact about pi over 6, I know this point about 11 pi over 6. And the same thing happens for the last reference. What's this arc length here? That one's pi over 3, and this one is 1/2 square root of 3 over 2. The x's and y's just flipped for that one. We saw that the other day. And so I can fill in the last 4 points. The last one, this was negative 1/2 square root of 3 over 2. And this one is negative 1/2 negative square root of 3 over 2. And finally, this one would be positive 1/2 negative square root of 3 over 2. All right, so you're going to want to keep this somewhere handy because you're going to use this a lot, I promise. Questions on that? All right, so now we're ready to start section 5.2. All right, today we're going to learn about trig functions. If I have a unit circle, what was a unit circle again?
1.
Radius is 1. Where's the center? At the origin. All right. So here's my unit circle. And I have on my unit circle some point right here. And that point would, of course, have an arc length, t. We're going to define 6 functions. The 6 functions are sine t, cosine t, tangent t, and then we're going to have cosecant t, secant t, and cotangent t. The sine of t is whatever the y number is on the point on the circle. What's cosine of t? The x, whatever the x point is on the circle, correct. What's the tangent of t? Anybody know? It's y over x. Very good. Cosecant? 1 over y. That's why I put sine next to cosecant. 1 over y. Secant? 1 over x. And cotangent. 1 over y over x, which is an easier to say x over y. You flip the tangent one. All right, so now we put these two concepts together, the unit circle together with these trig functions. So, this is the table you're going to memorize. That's correct. You will memorize this. So, sine of 0. So I look on my unit circle. Where's t equals 0? What's the terminal point for t equals 0? It's right here, right? 1 comma 0. So sine of 0 is the y number. So the y number right here is
0.
0. So sine of 0 is 0. How about the sine of pi over 6? Well, I look on my table. Where's pi over 6? It's the first point up that we hit. The y number right there is a half. And I keep going around my chart here. Pi over 4, the y number is? Square root of 2 over 2. Pi over 3? Square root of 3 over 2. And finally, pi over 2. The y number is 1. So all I'm doing to get the sine is I'm simply looking at the y numbers. A quarter of the way around my circle. How am I going to get the cosine values as I go a quarter of the way around my circle? It's simply the x values. So the x values go 1, square root of 3 over 2, square root of 2 over 2, 1/2, and 0. All right, so what do you notice about the sine answers versus the cosine answers? They're exactly the same, they're just in a different order, aren't they? So sine starts at 0, and sine goes 0, 1/2, square root of 2 over 2, square root of 3 over 2, 1. Sine starts at 0 and gets bigger. Cosine starts at 1 and gets smaller. Okay. Now, how about tangent? All right, so tangent, I've got to take the y number and divide it by the x number. But the y number is the same as what? Sine. Y is the same as sine. So tangent could be written as y over x. It could also be written as sine t divided by cosine t. So once I know sine and cosine, I really know tangent. I just divide the two answers. So to find tangent, I take 0 and divide it by 1. What's 0 divided by 1? 0. I'm going to skip this one because this one's hard. We'll go to the next one. It's easy. What's square root of 2 over 2 divided by square root of 2 over 2? 1. Why is it 1? Because when you take something and divide it by itself, you get 1. That's right. We'll skip this one for a minute and come back to it. What's 1 divided by 0? Undefined. Very good. So I'm going to put a big U there for undefined. All right, now let's go back to the other two. What's the square root of 3 over 2 divided by a half? Very good. So to divide those, I take square root of 3 over 2 divided by a 1/2. What Brandon said is you flip and you multiply. And what happens when you flip and multiply? The 2's reduce out and you're left with square root of 3. So that one happens to be square root of 3. And then this one's the hardest one. This one we have to take 1/2 and divide it by square root of 3 over 2. So again we flip and multiply. That's 1/2 times 2 over the square root of 3. What happens there? It's left as 1 over square root of 3, which is a correct answer. But the way you'll always see this written, it will be rationalized. What's rationalized mean? It's a fancy way of saying don't have a square root on bottom. So this is traditionally written as square root of 3 over 3. All right, so you see that much of the chart so far? You're going to go home this weekend and you're going to memorize that. Just that half. Because when you come in on Monday, there's going to be a quiz. And the very first question is going to be, fill in that table. I promise you, that will be the very first question on the quiz, fill in that table. You really need to memorize that. We will use that practically every day for the rest of the semester. It's not that difficult. Here's the way my teacher told me to remember it. This one is 0. This one is square root of 1 over 2. Square root of 1 is 1. So it starts at 0. Square root of 1 over 2. Square root of 2 over 2. Square root of 3 over 2. Square root of 4 over 2. So if you can go 0, 1, 2, 3, 4, you know the first line. Once you know the first line, you take the second line and you write it backward. And then the last one, well, 3 of them are really easy to figure out. So the only 2 you really kind of got to work on is those 2. Make sure you get those 2 straight. Okay? Like I say, this is extremely important. We will use this just about every day. I should be able to call you up at 3 o'clock in the morning and say, hey, what's the cosine of pi over 3? And what are you going to say? All right, so you're going to curse me out for calling you up and waking you up at 3 o'clock in the morning, but you should also know the answer. The cosine of pi over 3 is 1/2. That's how well you should know that. You should be able to be woken up from a deep sleep. Somebody asks you the question and you immediately know. So maybe I'll bribe your parents to wake you up at like 4 o'clock in the morning. You're going to be dreaming of it. You're going to be working so hard. That's right. All right, the rest of this table. I'm not going to fill in the rest of this table. You can go home and fill it in. But tell me, how would you do it? How would you fill in the cosecant row? So cosecant, notice cosecant would be 1 over y, which would be 1 over y is sine. So all I got to do is take all these numbers and flip them. So for example, when I flip 1/2, I get 2. Goes there. So this one's 0 over 1. When I flip it, I get 1 over 0. What's 1 over 0? That one would be undefined. Go ahead.
Are we, for the next one, are we expected to rationalize it whenever the comes out of like
the next one, when you flip it, you get 2 over the square root of 2.
Yeah.
And that's traditionally rationalized. It's traditionally written as square root of 2.
Whenever that's on bottom, are we expected to rationalize just like throughout the course of this?
Truthfully, I don't care if you rationalize or not. If you leave your answer as 2 over the square root of 2, I'll mark it correctly.
Okay.
But if you're working from your book and you look up information, they're going to write that one as square root of 2.
Okay.
This one, you would flip it. It would be 2 over the square root of 3. Again, traditionally, that's rationalized. It's written as 2 square root of 3 over 3. And this one would be 0? Not 0. 1. Because this is 1 already. If I take 1, 1 divided by 1, and then I flip 1 over 1, I still get 1 over 1, which is 1. All right. So I said I wasn't going to fill in the rest of this table. I guess I am. I'll do it quickly. 1, 2 square root of 3 over 3, square root of 2, 2, undefined. Same trick. Once I know the cosecant row, I know the secant row. The secant row just goes the opposite way because it's sine and cosine, same deal. And then tangent, same deal. To get cotangent, notice that tangent was y over x, but cotangent is x over y. So if I know tangent, to get the cotangent ones, I just flip them again. So it's all a matter of flipping stuff. So this is 0 over 1. I flip 0 over 1, I get 1 over 0. 1 over 0 is undefined. Let's go to this one. This one was easy. If I flip 1 over, I get 1 still. How did this one end up as undefined? It was 1 over 0. So if I take 1 over 0 and I flip it, I get 0 over 1, which is 0. What happens when I flip square root of 3 over 3? I get 3 over the square root of 3. And if I rationalize that, it turns out to be square root of 3. And this one's square root of 3 over 3. Questions on that? All right. So like I say, the top half of that chart, memorize it. Because you will have a quiz on Monday. It's going to be the first thing we do. Take a quiz. You'll fill that in for me. Oh, I don't know. I haven't written the rest of the quiz yet, but I promise you that's question number 1. There's probably going to be some stuff from section 1.1 on there too. I wouldn't be surprised. All right, next problem. Determine the exact value. All right, so we have cosine of 3 pi over 4. Which quadrant is 3 pi over 4 in? 1, 2, 3, 4. You got a 1 in 4 chance of being right. Third, and now you got a 2 in 3 chance of being right. It's in quadrant 2. Because this is 1 pi over 4. This is 2 pi over 4. 3 pi over 4 is right there. So 3 pi over 4 is in quadrant 3. What can you tell me about sine and cosine in quadrant 3? Which one's positive, which one's negative? I'm sorry, I said quadrant 3, I meant quadrant 2. So you got me confused. We're in quadrant 2. 3 pi over 4 is in quadrant 2. In quadrant 2, cosine is always going to be negative. How come? Because cosine is always the x value. So if I'm in quadrant 2, the x values are all negative. And what about the sine? Positive or negative? Positive, because I'm in quadrant 2, the y values are positive. All right, so here's the way I do this. I look at 3 pi over 4 and I say, all right, 3 pi over 4 is in quadrant number 2. What's the reference number for 3 pi over 4? Pi over 4. So I go to my chart and I look up the answer for cosine of pi over 4. Cosine of pi over 4 is square root of 2 over 2. But then I need to remember I'm in quadrant 2, and in quadrant 2, cosine is negative. So there's my answer. Negative square root of 2 over 2. Pretty simple when you've done it like 100 times like I have. Right.
Yeah, I know that.
All right, the next one, 5 pi over 4. Without doing any work, what's my reference number? Pi over 4. If it's got a 4 on bottom, my reference number is pi over 4. So I know my answer is going to have a square root of 2 over 2, because I looked at cosine of pi over 4. Now all I have to do is decide, is it positive or negative? Why do you say negative? Because it's in quadrant 3, isn't it? Because, again, halfway around would be pi, which is 4 pi over 4. So 5 pi over 4 would be just a little bit more. So I'm in quadrant 3. In quadrant 3, cosine is negative. Cosine of 7 pi over 4. It's going to have a square root of 2 over 2. And you tell me it's positive. Why do you say it's positive? Because it's in quadrant 4. In quadrant 4, the x's are all positive. So the answer is positive square root of 2 over 2. All right, how about tangent of negative pi over 3? What's my reference number? If I have a 3 on bottom, my reference number is always pi over 3. So I look at my chart. What's tangent of pi over 3? Square root of 3. So my answer is going to have a square root of 3. Now all I have to do is decide if it's positive or negative. So it's in quadrant number 4 because I start here and I go down. In quadrant number 4, is tangent going to end up being positive or negative?
Yes or no?
Remember, to find tangent, you take the y number and divide it by the x number. So one of the numbers is negative, one of the numbers is positive. If I take a negative divided by a positive, I always get a negative. So this is going to be negative square root of 3. Secant of negative pi over 3. Again, my reference number is pi over 3. So I go to my chart and I look up secant of pi over 3. That's 2. Positive or negative? I hear a reluctant answer positive. I hear a definitive answer positive. Why do you say positive?
Because I just looked at the circle. I saw that pi over 3 was in the first quadrant.
Okay, but we're dealing with negative pi over 3.
Because 1 over x and the x is positive.
All right, so we're looking at negative pi over 3, which again is in the 4th quadrant. But we got to remember that secant uses the x number, and in the 4th quadrant, x is positive. So this one will be positive too. All right, this time we have cosecant. We're still in quadrant number 4. In quadrant number 4, is cosecant going to be positive or negative? Because cosecant uses the y value, and the y values in quadrant 4 are negative. So we're in quadrant 4. We go to our table, we look up cosecant. There it is. 2 square root of 3 over 3. But we decided we were in quadrant 4, so it's negative. All right, so quite often you see something like this drawn with your quadrants. A, S, T, C. You can see all of it, couldn't it? So what this stands for, A stands for all. All things are positive in quadrant 1. S. S stands for sine, and then which one goes with sine? Sine goes with cosecant, because sine and cosecant both use the y numbers. So in quadrant number 2, sine and cosecant are positive. Well, the big T stands for tangent. So in quadrant 3, tangent, and which one goes along with tangent? Cotangent. So if you're in quadrant 3, tangent and cotangent are going to be positive. All the other ones will be negative. And if you're in quadrant 4, cosine will be positive, and the one that goes with cosine is secant. All right, so I've heard many different acronyms for ASTC. Anybody know an acronym for ASTC? All students take calculus, which of course isn't true, but that's a common one. Anybody ever heard of any other ones? All suckers take calculus. Okay, that's a good one. The one my teacher taught me when I was in high school was Albany State Teachers College, because that's where my teacher went to school. That's now called, not called Albany State Teachers College anymore. University of Albany. University of Albany started exclusively as a teachers college. When it first opened, the only thing they did was train teachers, and that's where my high school teacher went to school. So I remember it as Albany State Teachers College, but of course nobody knows that one anymore because Albany State Teachers College doesn't exist. All right. Anyway, let's try a few more of these then. 4 pi over 3. What's the reference angle? I keep saying reference angle because it's not reference angle. What should I be saying? Reference number is what I really should be saying. We'll see in the very near future that reference numbers and reference angles have a lot in common. So the reference angle is pi over 3. So I go to my table that I memorized, sine of pi over 3. Maybe I haven't memorized it yet, so I look at it up. Square root of 3 over 2. Which quadrant am I in? 4 pi over 3. Quadrant 1, 2, 3, or 4? You know, 1 in 4 chance of being right. Well, 4. Because 1 pi is 3 pi over 3. So 4 pi over 3 is just a little bit more. So I agree we're in quadrant 3. Sine positive or negative in quadrant 3? Negative. So my answer would be negative square root of 3 over 2. 11 pi over 6. What's the reference angle? Reference number. Reference number is pi over 6. So I go to my secant chart. I go to pi over 6. There's my answer. 2 square root of 3 over 3. Should it be positive or should it be negative? Well, that depends on what quadrant we're in. Positive. Should be positive. Why positive? Because I'm in quadrant 4. How do I know we're in quadrant 4? It's just a teeny little bit under 12 pi over 6, which would be 2 pi. So it's not quite all the way around, but it's close to it. So that's quadrant 4. All right, cotangent of negative pi over 3. Reference number. Pi over 3. Cotangent. Where is it? Pi over 3. Square root of 3 over 3. Positive or negative? Negative because it's in quadrant 4, just like negative pi over 3 was for the last problem we did. It's still in quadrant 4. Cotangent is negative in quadrant 4. All right, we got time to do problem 3, and then we'll be done for today, and then we'll finish this up on Monday. The terminal point for t is given by 6 over 7, negative square root of 13 over 7. Determine sine t, cosine t, tangent t, cosecant t, secant t, cotangent t. All right. What would sine t be?
Negative square root of 13 over 7, right?
Yes, why?
It's the y value.
Sine is the y value. That's exactly correct. So sine would be negative square root of 13 over 7. How about cosine of t? Cosine of t is the x number, so that's just 6 over 7. Once I find sine and cosine, how do I find tangent? Tangent is the other one, y over x. So tangent t is y over x, which is sine over cosine, which is negative square root of 13 over 7 divided by 6/7. And what would happen if I flipped and multiplied? I would end up with negative square root of 13 over 6. If you don't believe me, do the arithmetic and try it. But the 7s are going to reduce down. Okay, halfway done. How about cosecant t? You flip the y, so it's negative 7 over square root of 13. And as far as I'm concerned, you can leave your answer exactly like that. I do not care if you do not rationalize. And the nice thing is, when you do your homework on WebAssign doesn't care if you don't rationalize either. It'll mark that correct. So don't waste your time rationalizing. Unless you really like to do it, then you can do it if you want. Secant t. Flip the cosine. 7 over 6. And finally, cotangent t. It would be flip the tangent. It would be negative 6 over square root of 13. Okay? So once you know sine and cosine, finding the other 4 is really pretty easy. Do a little division, go flipping.